Hi, one more time, everyone. Welcome back to our statistics class notes here. We're in the last page of section 8.3, which is the last of chapter 8 for us, and page 134. And I just have a quick chapter 8 review here. Again, this is not all encompassing, but it gives us a little of the highlights of what I wanted you to remember from this chapter. So first of all, hypotheses are always statements about population parameters, right? They're not statements about sample statistics. It's always P equals for the null, and P is not equal, P is less than, or P is greater than. Both of these are for some value P naught. Okay, so they're statements about population parameters. Now, in hypothesis testing, if the null hypothesis is true, the test statistic, our z-score that we're going to compute for our p hat, is likely going to be close to 0, which would make it close to the middle, right? Which is where we assume the truth is. The null hypothesis assumed from past information to be p naught. Our test statistic would be close to that p naught, which is 0 when we change it to a z-score. So the z-score would be close to 0. Now, there is strong evidence against the null, right? Which means that our test statistic will be a long ways from the middle. So the p-value itself is going to be close to 0 because the p-value is the probability of getting the test statistic that you got, or one more extreme, the area in the tail. So if there's strong evidence against the null, in other words, to support the alternative, the p-value is going to be close to 0. So it'll be less than alpha. Now, if I'm conducting a left-tailed hypothesis test, that means our alternative is that p is less than the assumed middle of p naught. Which of the following test statistics would provide the strongest evidence against the null hypothesis? It needs to be a large negative z-score. So the test statistic is a z-score, so this is the largest negative, negative 2.78. Now this 2.95 is a big z-score away from the middle, right? But that's on the right side of 0, the middle, or p naught, before we change it to a z-score. So its p-value would be all that area to the left of it, which would be huge. Right? We want to test statistic that's way out towards the left tail to say we have enough evidence against the null. All right, and in this example, in 2010, 48% of voters in a certain state were opposed to the death penalty. A researcher conducted a hypothesis test to see if this proportion had increased. So he thought more people were opposed to death penalty, a higher percentage. The alternative hypothesis was that P is greater than 0.48. The test resulted in a test statistic of z equals 1.27, so gut reaction, not big enough yet, not big, but a p-value of 0.10, so it might be close. Which of the following is an appropriate conclusion for this test? I would still say not a big enough z-score. I'm not giving you the p-value, so the best answer here is there is not enough evidence that the proportion has increased. Okay, so assuming that we get alpha of 0.05, the p-value would be bigger than that, right? So, this would be p-value is bigger than alpha, not less than alpha, right? There's not enough evidence the proportion has increased. P-value is bigger than alpha, greater than.